Hello and welcome. Today we'll be looking at mensuration and our focus will be on the perimeter of circles, squares, and rectangles as well as their areas. I'm Teacher Walton. God's word in James 1:6 says, "But let him ask in faith, nothing wavering. For he that wavereth is like a wave of the sea, driven with the wind and tossed." My declaration is when I pray, I will ask in faith and not doubt. Amen. Let's go to question number 1. Here we have a circle inside of a quadrilateral four-sided figure. And the question asks us, is the quadrilateral a square or rectangle? Remember, one of the properties of a circle is the diameter will be the same. So if I were to draw the diameter horizontally and vertically as shown by the two red lines, remember the diameter here will be the same as these two sides in length, and the diameter going across will be the distance for here and here. So you notice how all four sides of this quadrilateral is of the same length, and that is the property of what? Of a square. So the explanation is it is a square because the diameter of the circle is the same as each of the length of the square. So therefore the four sides will be equal. Let's go to part B. We are told that the radius of the circle is 14 centimeters. So if radius is 14, diameter is twice radius, so the diameter will be 28 centimeters. We are asked in B part 1 to find the circumference of the circle. So let's go to B part 1, circumference of the circle. You can either use the formula 2 pi r, or you could use the formula pi by diameter. Let's use the second one. We're using pi here as 22/7, and we're multiplying this by the diameter 28. So the circumference, 28 can be divided by 7 4 times. The circumference will be 88 centimeters. Circumference is the same as the distance around the circle or its perimeter. What is the difference between the perimeter of the square and the circumference of the circle? And that is part B. Let's go to part B. What's the difference between the perimeter of the square and the circumference of the circle? The diameter here for each side of the square is 28 centimeters. Right, so we got this from up here. So to find the perimeter of the square, what we can do is multiply 28 by 4. So the perimeter of the square would be 28 by 4. 8 4s are 32, 4 2s are 8, and 3, 11, 112 centimeters. And the difference will be 112 minus 88. And this will give us 24. What's the area of the shaded region? Okay, so I'm glad you asked. The area of the shaded region, which is shown in gray, will be the difference between the area of the circle, which is in white here, and the complete area of the square. So let's work out the area of the square first. The area of the square will be side by side. Now we know the side is 28, so it will be 28 by 28. Let's get the help of our calculator for that. 28 by 28. 784. Okay. And let's work out the area of the circle. Area of the circle using the formula pi multiplied by radius squared. So we need to be careful here. The pi is 22/7. Our radius is 14. And we are squaring this. So let's square 14 first. All right, so 14 squared. And let's multiply that by 22/7. Great. So that'll be 616. So something I forgot to write upstairs there. When you write an area, you must write it in square centimeters. So this will be 784 square centimeters. And if we are to find the shaded region, we're going to take the difference between 784 and 616. Right, and we can work out that quickly here. 784 minus 616. And borrow 1 here, 7, 14, 8. All right, so it's looking like 168. So that's the difference, 168 centimeters square. Okay. Right, so 784. So we good with question number 1. Let's go to question number 2. Right, question number 2. In the figure below, the radius of each of the semicircle PS and QR is 3.5. So let's put in that information. Notice this is a semicircle, and we can complete the diagram by showing the actual semicircle at the end of this figure. So we got 2 semicircles. And remember, if you bring 2 semicircles together, they form 1 complete circle. So if the radius of each of the semicircle is 3.5, it means that the complete distance, which will be diameter twice the radius, will be 2 multiplied by 3.5. So this distance here from Q to R would be 7 centimeters. Same thing across here from P to S. If the radius, remember radius is half the distance, so the radius would be like from the center here to one end. If that's 3.5, then the complete distance will be 3.5 plus another 3.5, which will equal to the diameter of the circle. So that's the reason why we write 7 centimeters here as the diameter. Right, let's see why that is important. They give us some more information. PQ and SR, the distance P to Q. Right, P to Q is up here. And SR, they are both 18 centimeters long. And we are taking pi as 22/7. Find the perimeter in centimeter of the figure PQRS. So perimeter is distance around. So it means that we must find this distance here, right, on the edge of the circle. And we also must find this distance here. So remember what I said originally? That if we bring 2 half circles together, 1 half circle here, and we bring another half circle here, and we're interested in finding these 2 distances there, it will give us the complete distance around the circle. So to calculate those 2 shaded regions in yellow, we can simply find the circumference of this circle as shown here with a diameter of 7 centimeters. So let's do that first. So the circumference of the circle will be pi by diameter. So if pi is 22/7, diameter here, we agree with 7. So the circumference will be 22 centimeters. So the two distance shown in yellow will be 22 centimeters. Then we must add the 18 and 18, which is 36. So the perimeter of this circle will be 36 plus 22, which will give us 58 centimeters. Let's go to the next question there, part B. What is the shaded area? Excuse. Right, so the shaded area, again, if we see this as the area of the semicircle, and we also see this one here as the area of the semicircle, when we bring them together, we get the area of a complete circle, right, as shown here. So we can find the area of the complete circle. Why are we doing that? Look carefully at the shape. The shape is really a rectangle minus those shaded portion in yellow. Are you seeing it? We can see that you have a rectangle here shown in green. And if we subtract the area, if we find the area of the rectangle first, and we subtract the two portions in yellow, we'll be left with the shaded region right there. So let's do that. We agree that the shaded region in yellow represents the area of the circle. So let's find that first. Area of the circle is pi by radius squared. So remember our radius here is 3.5. So we are taking 3.5 squared and multiplying that answer by 22/7. Let's work that. Right, 3.5. Let's square that. That's 12.25. And we're multiplying this by 22 divided by 7. Okay, this will be 38.5. So the area of the circle, excuse, is 38.5 centimeters square. Let's work out the area of this rectangle. To find the area of a rectangle, we are taking length multiplied by breadth or width. And the length here we agree is 18, and we're going to multiply that by a width of 3, not 3.5 by 2, which is really 7, right? So we have all the dimensions here already on the diagram. And 18 by 7, let's work that out. And of course, we're going to subtract the 38.5 from that answer to get the area of the shaded region. So 18 by 7 equals, so it's 126 will be the area of the region shown in green, that green rectangle, the area of that. And then when we subtract the cutout piece, which is really 2 semicircles, area of one circle, which is 38.5, we are left with 87.5. So the area of the shaded portion would be 87.5. Okay, let's do what is just writing the answer, 18 by 7. Right. So we got 87.5 centimeters square. And the area was 126 of the rectangle. So let's put that right here. 126. So to get this 87 centimeters square, remember, we have to take the 126 and then we subtract the 38.5. Okay, well done. So that brings us to the end of this session. Thank you so much for joining us. Until we meet again, God bless.